try it now. All right, green light. Let's see if it works, YouTube. And hey, it's live. Hooray. All right, so now it's streaming. So what you're going to be able to do when you're all done here, usually after class at some point, although I'm not super quick with it, I'll put links to the videos, just the YouTube videos on the class webpage. But you can also subscribe to my YouTube channel. I have a link to it somewhere in the syllabus, so I'll show you that in just a moment. So the first thing I'd like to talk about is structure for the course. I try to do everything electronically. By the way, I try to stream my courses because a lot of times I want you to, it's hard to take notes and pay attention at the same time. And I'm prone to talking a lot and probably too fast. So this is a way that you can go back, hear things again. Maybe you don't dare not to take notes and just live in the moment and have to go back to a part of class, you can go see it. You can do that. The other part of it is you're welcome to, if you ever have to miss class, you can miss class and see this. I had students before watch this from around the world when they've been on wherever trips they might be on. But I encourage you to be in class. It's probably a better experience in class because I won't be able to see your comments. I don't have a box that I put up where you can ask questions or put comments through. And sometimes the stream lags a little bit, so class may have moved on before then. There's probably better ways of doing it, and if you know them, let me know them, but that's that. So the syllabus itself is on the course website, sort of the same material. There's the information that you need to know. You probably know where to find my email address. This is the course website, so it's kind of redundant. My office is in room 224B1 of the Lindquist Center Southside, which is right next to the Statistics Outreach Center. So if you need to find me, I'm there. I'm going to try to have office hours. Escrowed. Nope. You are fired. If you are going to interrupt my class because of class management, I'm going to, excuse me. I do not like managed notebooks by the university that interrupts university business, including university lectures. And so now I am going to have to do something about this. It's probably not good. Anyway, I don't know what good is, but we'll figure it out. So Lindquist Center South, I have an office phone. I'm supposed to put it in my syllabus, but I never use it. So just email me if you have questions. Office hours, 11 to 1 on Mondays or by appointment. So that's what I'm planning on doing, although this upcoming Monday is a holiday and I will not be here on campus. So not this Monday. Email me. The other thing I'm planning on doing is putting my course materials on GitHub. So there's a GitHub repository. How many of you know Git? Know a little bit about it? How many of you have used it before? All right. It's not necessary that you use it, but you're welcome to. And the reason for that, what I'm trying to do, I just ran out of time, to be honest with you. I'd love to be able to administer the class through GitHub. There's a GitHub classroom now that I was trying to get into to see how it worked. And I haven't quite figured it all out, and it was going to take more time than I had to build the class. But as the semester goes on, we may get into it more. But what this means is you can go and always download all of the R files for the class here. And starting next week, pretty much every course lecture is going to be an R markdown file of some sort. It may be slides, it may be otherwise. So they're going to show up in here as well. The PowerPoint slides I have for today are going to be sort of the old standard, although they're not deprecated completely yet. I still have some value because it got me through to teach this class right here. So syllabus also shows up here. The other thing with GitHub, if you know how to do it, is you can take a fork off of the main repository, make some modifications, because I make a lot of mistakes. But if you catch anything and you want to fix it or you want to contribute in some way, you're welcome to take a branch, do so, push it back to me with the merge request, and I can add it to the repository if you'd like. You can be a contributor to it if you'd like. So it's more just trying to make this more of an open source class because I'm a big believer in a lot of the open source world itself. Okay, again, any questions you have, please don't hesitate to ask. We have a textbook that I had sent a request to the university last fall to list on our course that was unsuccessful somehow. So I list it here. There is a link. The University of Iowa has this textbook as an ebook. You are able to read it online if you'd like to. So it's Bayesian Psychometric Modeling by Roy Levy and Bob Mislevy. Roy's a friend of mine, and Bob is a giant in our field. I have, full disclosure, have not read the book fully yet from cover to cover, but it gives me what I need, I think, for this class itself. We doing all right so far? This is very dry. I feel like I need to have like juggling or a flamethrower of some sort. And this is an odd setup. The course itself, what are we trying to do here? It's a unified Bayesian modeling approach that across psychometrics. Basically, my thought in teaching this class first is that it's a couple of reasons. My research area is often thought to be diagnostic classification models. That's sort of the area that I've grown up in, people know me for, but to really do that area well, you have to do Bayes, because the methods out there for estimation, even though they look like they're working well under the hood, they don't work very well. They're not very stable. They don't do very many dimensions. They don't do things very well. Whereas Bayes works much, much more fluidly, much better for a lot of reasons. So I'm a big believer in Bayes first. The other reason for that is it helps me understand a little bit about what you know and what the course, I'm so new here that I don't know enough about what happens in each of the courses and where your preparation is and so forth. So it helps me get to know, as a sort of a focus group, some qualitative research in here of what you know about the models and how we want to talk about it. So the book itself has an introductory section that talks about kind of the theory of Bayes and Markov chain Monte Carlo estimation. But then the second half of the book, and actually I take that section, I do that over the next 2 weeks. There's lots of chapters there, but they're pretty quick reads, I think. There's not a lot of heavy lifting in the formula and so forth, formulae that are in there. So that's going to be kind of shove that first half away. And so when we jump into the rest of the class is all about the models. And it's effectively how to do Bayes, starting with the setup of models, how they are, where the commonalities are, how they work, but also CFA, starting with CFA. I like how the book has a chapter on classical test theory that comes before CFA, but we're going to roll that into CFA because it's subsumed within it. So don't need to do that. Don't need to worry about that too much. But I like how they put model fit evaluation after CFA. So model fit often works very, very easy in CFA models relative to all the other psychometric models that are out there. So we'll do that. We'll also get into IRT models. We'll spend a number of weeks in IRT. I broke up chapter 11 into dichotomous models versus polynomous models. There's a ton of them out there, as you know very well. MERT models as well. And again, I'm not assuming each of your backgrounds. Some of you may know these, some of you may not. That's okay. We'll be able to work through each part as we go through. There's no class for spring break. There's a chapter on missing data, which I'll probably supplement with a number of other materials too. There's also no class the following week. How many of you go to AERA? A lot? Yeah, well, I won't be here. Never mind. I'm flying that day. Never mind. You can go to AERA, but you can come here, I won't. But no, there won't be class there either. So it's a little odd part of the year by spring break. But afterwards, we start getting into more and more really interesting parts. Latent class analysis. Is that taught in any of our classes for our EMS program? I don't know that we have that. Latent class analysis, latent class models are, if you think of the history of psychometrics, there's a big, big book, the Lord and Novick book. Right about the same time, another book came out by Lazarsfeld and Henry in latent class analysis, and that's also very big, but in a different direction. Those models are very flexible. They do all sorts of things. The identification of it is really, really interesting, how you end up, especially compared to a CFA or IRT model. But the latent class models helps lead into diagnostic classification models, which is my topic. If you don't know what that is, great. That's what you're here for. Bayesian inference networks, what are those? It's just a fancy name. But hopefully by the time we get there, you'll understand that all these above fall under the Bayesian Inference Network umbrella. It's just a big name for it, but the Bayesian Inference Network is heavily informed by engineering computer science. So you'll see a lot more graphical models and so forth in that. And because of that, the last class I'm hoping to do on Bayesian belief networks, which are sort of my foray into like AI and machine learning and how psychometrics kind of can touch there as well too, sort of the differences between fields. So I'm trying to get a little bit of that in this class as well, at least from my understanding. It was my perspective. I'm trained in psychometrics. I'm a psychometrician. My birth certificates for my children don't list my job as professor. It says psychometrician, so that's me. But that being said, the world is changing and we need to change with it. So I think that's important. Questions, comments so far? Sound all right? Anybody, if you'd like to walk out, stomp out right now that doesn't what you want, go ahead. No, just kidding. Just make sure it's a big, throw something down and yell, ugh, leave in a huff. That'd be kind of fun. Things I think are fun. I'm trying to make this more fun than just syllabus and blah, blah, blah. You've had a whole week of this, right? This is like the first class of like everything. I don't know. Anyway, I don't know icon yet, so I'm gonna figure that out. But then again, when I was at Kansas and I've worked at too many universities. I'm hoping to not move anymore. It's my fault too. I can't keep a job. It's like what's the incentive to learn a new thing when you're like, the world is changing. But no, I steadfastly refused Blackboard before when I used to be at the other campuses, and I probably refuse icon as much as I can here too. So that might be a problem. But I try to put grades on there, and we'll talk about grades in just a moment. I need to silence this. I'm sorry. There we go. All right. So there you go. Everything is on my website or on the GitHub repository. I sort of mirror both right now. And the YouTube channel, you can click that link and find it there. I should put that up on the top of the page. Do that later. Everything that we do from this point forward, with the exception of today's PowerPoint, will be in R. And I shouldn't say everything. Most everything will be in R or R Markdown. R notebooks and R Markdown. So the homeworks as we're building to here are going to be R Markdown. Or actually, this first homework doesn't have to be Markdown. It's okay. So if you don't know R Markdown, that's great because it's an easy way to embed R with text. And this is a chance to get some experience with that as well. And I found Markdown documents to be exceedingly useful because you can change them. It's just plain text. You can read them on any device. But then there's a program called Pandoc, which actually RStudio uses to turn them into different formats, so HTML or Word documents or whatever else. They really automate a lot of the things, the repetitive things that we do. Heck, you can even, there's a package called Papaya, thank you. I'm anglicized. My grandmother was from East Anglia, so Anglo, whatever the word is. Anglification? No, I don't know what it is. Anyway, Papaya is, it takes R Markdown, turns it into an APA document, which is pretty cool. APA formatted document. So that's pretty cool too. So you can write your papers in it. Let's see. So to get R, you probably know where R is. RStudio is pretty much what I use for everything because RStudio gives you the R Markdown. But then when we get into Bayes, what we're going to use for Bayes, and I didn't put this in through every, we're going to use a program named JAGS. JAGS is a short for just another Gibbs sampler. If you're familiar with Bayes programs out there, JAGS is like it says, not wholly unlike bugs. That sounds very English. It's effectively, anybody who knows open bugs or WinBugs pretty much knows the same syntax for JAGS. It's pretty much a straight ripoff. Not entirely, but it's, at least the syntax is very common, which is nice, actually. It's not even a ripoff, it's an open source. WinBugs is open source, so it's actually good. I've heard things that WinBugs is sort of not being developed anymore, but JAGS still keeps coming out with things, so that's part of the reason. The other part is there are other packages out there that we could use, and I steer away from them, as we'll know for a little bit as we get into class. One of the more popular things these days is a package called Stan. Anyone ever use Stan? Anyone ever tried to install it? How long did it take you?
I just started using the R package instead.
Okay. Yeah, Stan is actually a really nice piece of progress in many ways. It's harder to work with. It's hard to install. But for our purposes, and the reason why I really want to teach with JAGs, is that Stan can do models where you have parameters that are discrete. So this, if we go back to the syllabus here, our latent class models are models where the latent trait is categorical. Now Stan will do that, but they won't actually do it. You have to go and marginalize across the likelihood function to do so, which is a mess. And so to try to meet the mission of trying to teach what the models are in addition to the Bayes part that goes with it, JAGs allows for discrete traits to show up in. So it's much more direct. There is no reason that you couldn't take the machinery that JAGs is using, and we'll talk about why Stan does that actually as we go forward. We'll talk about what the difference in the algorithm is. And the nice thing about Bayes algorithms, if you get to know them all, you can mix and match. So there's no reason why one of you couldn't take your own version of JAGs and combine it with your own version of Stan and have it do both at the same time. It wouldn't use the Metropolis or is it not? Excuse me. It wouldn't use the. God, I'm blanking. The words that blanking on this here. The method that Stan uses, it's the hybrid Monte Carlo or Hamiltonian. Thank you. Gosh, I have to look away. That's it. LeBeau. I don't know why. Anyway. Sorry, this is nerves coming through, I think. The latent class model, there's no reason you couldn't combine that with like a Metropolis algorithm as well. Actually, there's another form of a different type of sampling for Metropolis. Metropolis Hastings within gives with it with a step for the discrete parameters. You could do both simultaneously if you needed to, I think. But we'll talk about that later as we go forward. So JAGs is our big software that we're going to use here. There are other packages out there you probably have seen or may have seen. M+ has a Bayesian part to it. And the difference between M+ and JAGs is M+ will do the coding for you of the model, which is nice, right? But I want to teach you the models. So to teach you the models, I need the part that does that. But what I'm hoping is what you'll learn from this class is a little bit more about what M+ is doing behind the scenes. And you can go back and use M+ when you want to. I think it's a lot easier to pick up than JAGs is, but it's 6 of one, half does the other at some point. But for didactic purposes, I'd rather use JAGs to teach you the models. On top of that, you may have also seen proc MCMC in SAS, which is cool. And actually, it's very similar to JAGs. I just have gotten away from SAS over the last few years, so do that. I think Stata has an MCMC, some type of MCMC thing on, but honestly, I've never installed Stata on a machine in my life, and it probably won't start right now. So my next battle is conquering Python. So it's not Stata. It's not on the list. So, all right. If you want to use Git, if you're on Windows, you'll have to get a Git client. But if you're a Mac OS or a Linux OS, you can use the command line to use Git. And I'll get into that as we get through class a little bit more next week for how to do that. So any questions? How am I going to evaluate you? It's real simple. We have 7 homeworks. Sorry, a maximum of 7 homeworks. I can't guarantee all 7, but I can tell you there'll be a max of 7. They're all take home. They're all about 2 weeks time. And the very first one, how many of you know R or at least use R a little bit? Does anyone not use R? Okay. If you know R and use R a little bit, I didn't want to assume everybody knew R because this is me knowing what the people are like here. At Kansas, it was very different for the population. The first homework is something that we call Make Friends with R. You can do that probably in no more than 30, 40 minutes, my guess is. And there's an example file that I have on the website to show you as well. I'll talk a little bit about that toward the end of class today too, okay? So 7 homeworks. The first one is, if you know R, probably like, come on, really? But it's more my understanding of where people are, so sometimes I have to come in. It's one of those easy items if you know R. But if you don't, that's fine too. If you know R just a little, that's fine. Hopefully you'll learn R a little bit more. And if I don't want to minimize any of this, if you don't know R and you see everybody else raising your hands, you were like me in grad school, I'm like, I'm not going to raise my hand. I will work with you. That's not a problem. You're here to learn. That's what I'm here for. So it's great. We will make this work, okay? The grades are pretty straightforward. Oh, part about that. 7 homeworks. I try to hit up all of the big topic areas in class, starting with linear models, which are just like regression. But that helps us get through the intro part of the class. And also gets us used to getting JAGs installed, getting R to work with JAGs, all the other things. So we sort of, the harder part of the class, if you want to call it that, will be the homeworks that deal with the psychometric models. They'll take a little bit more time, but they'll give you experience in coding and you should be able to do them. They're not going to be overwhelming though. The other part of it is that your homework, each homework counts for 15 points, so they're equally weighted. 7 times 15 is 105 total points. So depending on what your score is, here's the grade that you get. But the cool thing about all that,
Is this class in Bayesian method?
yes it is. The grade system is right there. You can figure out how you want to do, but the cool thing about homeworks is if you, I allow you 1 revision for the homework. So you turn it in, I grade it, something wrong, fix it, turn it in again. I'll tell you how long you have to do that. But the point of that is I want you to learn, master the material. This isn't some, I'm a big believer in mastery learning and trying to understand stuff before you go forward, and having multiple chances at the same material will hopefully be able to achieve that. So that's where I go with it. There's no course project, there's no test. The reason why I don't do tests is because I want you to be able to do this in your career, and there's very few times in your career where you're like, all right, ready, set, code, right? I need you to code for me in an hour, right? I mean, that may happen in some places if you got a deadline or whatever, but it's not quite the same as ready, set, statistics, right? So what I'm trying to say is I don't know that that's valid for learning the material where you need to get out. Question the validity of our tests, my tests, what I could give. But the other part of it is I don't give a homework, I don't give a project, because a lot of times the people I find want to do the stuff at the end of the class that's fun, and then you have no time to do the project. So what I say to that is, if you find an idea for research that you want to do after the class, I'm happy to work with you on that too, but we don't have to tack it onto the class itself. Finally, the last thing, because I like to give out feedback, I want to grade your homework and get it back to you quick so that you can revise it if you need to. I ask that you don't turn your homework in late unless I know about it ahead of time. Now, I know there are some emergency events that may prevent that. That's cool. I get it. I will not have a problem with that. But in general, if you're like, oh, I can't turn in my homework because I'm going to this conference, you tell me that the day of the homework is due, that's sort of what I want to avoid. If you do have a situation where you need to turn it in late, let me know ahead of time. I'm flexible about that. But the reason for that is I want to be able to give back feedback quickly so that you can turn it, so it's still fresh in your mind, and then you can go revise it. And that's, late homework sort of slows that down. So there's a 5-point, just a 5-point penalty though. So even if you turn all of your homeworks in late with 5 points off, you still, well, I guess it drops your grade down here, but that's okay. You probably don't want to do that. Depending on your other grades, you probably will survive. It's not a big deal. I don't know. I always have this thought in grad school that grades are important up to academic probation, right? Like, how many people are going to look at your grades when you go on somewhere else? That's right. They're going to look at which courses you took. They're going to look at who your advisor is, what you've published, what you've tried to do in grad school, what you know. Nobody is going to be concerned about grades. So I'm pretty lax about all of this. It's pretty easy. Finally, the additional information about the syllabus you can find at the bottom. These are sort of boilerplate things I understand we're supposed to add. if you need it, if you're in need of accommodations for anything in the class, please let me know. And finally, absolutely, I absolutely have all respect for any type of diversity in this class, regardless of whatever you are. If you're on this planet, you're respected. All right. If you're someone who are in another dimension, well, you're still. If I can see you, the projection of you is here on this planet. That's how it is. It doesn't matter what you believe, who you are, and I actually expect that also of everybody in here as well. And so I expect in a lot of these classes, one of the bigger things in stats is some people are really quick to get it and some people aren't, but that's okay, right? There's no questions that are too basic and there's no questions that are too advanced. So if you hear an advanced question, don't worry. Someday you will get there too. Don't let that be a reflection of yourself. Or if you hear a basic question, don't go, oh, there was a point where you might not have known this either. I don't remember doing this in kindergarten. So try to tell. Anyway, the other part, the most important part though, this is a 2.5-hour class, and I'm going to give you a 10-minute break about halfway through, which is about 10:25 if I did the math right. Right? Help me out here. 60, 120. So it's 150 minutes divided by 2 is 75. 75 minutes after 9:30 is about 10:25. So there's maybe a 10-minute break there. Does that sound good? What's that? 10:45. What's that? Oh, no, maybe that's it. 10:45. 10:30. Yeah. So then going 10 minutes on the other side would be 10:40. 10:40. 10:40. So we got a little while. So there is a break. You'll be able to get up and stretch and do whatever. But if you need to leave, go ahead. Use the bathroom, whatever. We're all adults here. There's no hall passes. Okay. Okay? Any questions? Nope. As you can tell, I don't have an attendance policy either. So, I like it when you're here, but more importantly, I'd like it for you to want to be here. I'd like for there to be something in here that you want to see, so to be worth your time. So that's important, but it's up to you. So without going any further, I'm going to dive into the lecture if we have no other questions. You can find the lecture slides again on the website under this little table right here with the course introduction. There's lecture slides here. There's also R files in a zip folder that you will find right here. There it is. And so here, there'll be our file that goes through for the first part. When we get into the psychometric model, I had to do this last night. I was like, oh, I need another example. So I put another example. I thought about making it shiny, but I just decided just to punt on that and play around with it in class. So, and then finally, I'm not going to cover this, but this is for the homework. There's a Make Friends with R example file that talks about how to do lots of things that are in the homework. If you've done R before, you will be able to use that just fine. The homework itself is at the bottom right there in a zip folder. Okay? And again, questions on any of that, if you prefer after class, just send me an email and we can find a time to talk, or we'll make it work. It's due 2 weeks from now. And when I say due on February 1, I mean that means like 11:59 p.m. that day over email. So nothing that's printed out, nothing else that works like that. Okay. Quit rambling. Let's do this. Here we go. That's right. This screws up my streaming if I do it wrong. So let me do this. I'm going to end up having to put this on here, mainly because I don't know if you've used PowerPoint and Mac, but I haven't found a way to keep it from going to presenter view as we go. And what that means is the stream itself online now has 2 to look at. Oh, there it is. There's the stream. Is it frozen? It is frozen. So let me stop. Yeah, we'll start this again. Okay, do we get a green light? File vault encryption, my goodness. All right. And then just double check. All right, we're live. Actually, it's frozen still. Let me just. All right. There it goes. Thinks it's live. The internet can totally see you now. But is it seeing what I want it to see is the question. Yeah, dang it. This is why I got away from Microsoft in the first place. All right, we're gonna have to try one more time. Haha, I think it's working. There it is. Okay, so my bad. Never use full screen mode in PowerPoint if you're gonna do this. This is another reason why forget it. Forget it. All right, today, Bayesian overview, an MC overview, and a psychometric model overview. I will note that those of you probably in the other class that they taught that not all Bayes is Markov chain Monte Carlo. Right, there are other estimation methods to use in Bayes, but it's frequently conflated that way. And for most of our class, our Bayes is going to be Markov chain Monte Carlo. But today, let it be said that not all Bayes is Markov chain Monte Carlo. There are other ways of getting estimates without MC. In fact, we've been doing those methods in the testing world for many, many years, going on 40 years now at least, if not a little bit more. So, let's get an intro to Bayes statistics. Bayes statistical analysis refers to the use of models where some or all of the parameters are treated as random components. So you are telling basically, when you form a model, you have to specify that each parameter comes from some type of distribution. This is no different than you have probably seen in your linear regression model, because there was error in the linear regression. You would say error would follow some normal distribution with a mean of 0 and a common variance, or homoscedastic variance to make that work. So in the Bayes setup, there's several components, and if we get into Markov chain Monte Carlo, there may be even more. But the part that drives the model itself and how we find the numbers from the model is a likelihood function. Right? There's actually two parts. It's a likelihood function that talks about the way that the model takes the data and links parameters to data effectively. Essentially, the likelihood of the data given the parameters. And there's a second part of that that's a prior distribution that says for each parameter, what is your belief as to how that parameter should be distributed. And the result, actually, let me just back up. Those prior distributions are sort of talking about how much certainty you have in the parameters themselves. That's where it is in some respects. There's other ways where the prior distributions have to be there for identification. For instance, in an IRT model, often we have to put some type of distribution on the ability parameter, theta, which I'll usually just call theta. Otherwise, we have some issue, although not all models have to do that, and not all ways of estimation have to do that. There's nothing that's hard and fast about all this, but what I'm talking about is for the vast majority of cases that you'll see it. So in that case, when you have a likelihood function that takes parameters and data and makes, kind of links parameters to data, that's the model. That's the part that we talk about as a model itself. That's where the math comes in that you write for each of that. And for our measurement models, that will be kind of the part where the items touch the latent variables themselves. But that being said, each component of the model may have a slightly different likelihood function. So in a linear regression, the likelihood function is what the distribution assumed of the outcome would be. In this case, it would be conditionally normal, right? Or normally distributed with a mean that's set by the linear regression itself, the linear model function itself, and some common variance. However, in measurement models, you're still going to see that same likelihood function for something linking the latent trait to the data. But then what's the likelihood function of the latent trait itself? And so there'll be another likelihood function for or pardon me, what's the likelihood function for the distribution of the latent traits, right? So that's a little bit weirder because the latent traits link to data. But if you're going to have let's say you have a 3-dimensional confirmatory factor analysis model. And so you have 3 dimensions and you describe that with just an unstructured covariance matrix between them, right? So that covariance matrix, the parameters of it, don't use the data as its likelihood function. It's going to actually use the latent traits. Okay? So that's what it's an instance of what we call a hyperparameter itself. So what is a likelihood function? When we get into psychometric models, when we get into multi-level models, the definition of likelihood function might change depending on the type of parameter you're trying to actually estimate itself. But it's still the same philosophy. There's a likelihood function, there's a prior distribution. The result of combining both of those is a posterior distribution. So Bayes analysis is all about getting a posterior distribution, which is what we would describe as the distribution of the parameter given the data. That is the big point. Now, posterior distribution. It's kind of interesting. When you do frequentist statistics, and let's imagine you, again, simple linear regression, you get a regression slope. You do a simple linear regression model, plug it into, I don't know, you could do it by hand, do it in Excel. There's a test statistic that goes with that, right? That's describing that's based on some type of distribution, right? How is that possible in frequentist statistics, but not in Bayes? But also in Bayes? Anybody know? Why do we have that? That's asymptotics, right? As n goes to a very large number, wherever infinity happens to be, that's sort of the limiting distribution of the parameter itself. We say that parameter converges in distribution to often a normal distribution, although depending on the way that you do so, if you're in a regular linear regression, you may have a t distribution depending for a finite sample with a certain number of degrees of freedom. So that brings up the other point that's interesting when you're sitting there in frequentist world. When I was learning Bayes and learning frequentist, it looked very similar because in frequentist, I get a parameter and then all of a sudden I look over different columns of the output to the right, and there's a p-value, and the p-value has to come from a distribution. I didn't say there was a distribution for that parameter. How did it get there? It got there because of nature, right? That's what I'll call it. Is that a good way of putting it? It's the law. Right? There's several terms for it, right? The law of large numbers, Slutsky's theorem, and I'm sure these gentlemen over here probably describe more of it than I can. Certainly in my anxious state at the moment. But that law right there, a lot of it is based on the likelihood function for the data itself when you are in a frequentist world. So this likelihood function in Bayes and the likelihood function in frequentist are common. They're shared. They're the same thing. They look different. There's a Bayesian flip-in notation, right? The likelihood of the data is what we call it in the maximum likelihood world, right? Actually, it's likelihood of the data given the parameter. Otherwise, likelihood of the parameter given the data. Anyway, so what happens in Bayesian, with the point I'm working to, is still the same frequentist properties of convergence as n goes up apply in Bayes as well. So if you're like me, the skeptical Bayesian, or better yet, I like to think of myself as pragmatic. What that means is if you have a really big sample of observations for a parameter in that likelihood function, unless the prior is really, really, really specific, and I mean like has next to zero variance in it, you're going to find almost the same result when it comes to the asymptotic distribution of the posterior. It will converge. It may converge faster, it may converge slower, depending on priors, depending on how you're actually working. And by convergence, I'm not talking about Markov chain convergence. This is more the distribution itself is a good characteristic of it. You've reached infinity, or close enough to infinity where the properties of asymptotics kick in. Does that sound good? A little bit different. So yeah, why do people use Bayes? And this is an interesting slide because I think I wrote this first version of this in 2012. Lisa Hoffman, Dr. Hoffman, and I co-taught a class at University of Nebraska it was our version of multivariate. We sort of tried to retool multivariate into like a modern world. We had Bayes in there, we had missing data, we had all sorts of stuff. But it was based on likelihood functions. In fact, with multivariate for me is like likelihood functions. The rest is how do you get to it. And I started writing this down, missing data, blah, blah, blah. Why do people use Bayes? Right, let's try to figure out. The first one I thought of at the time was missing data. I hate saying multiple imputation. I just had a conversation yesterday with somebody who actually said exactly what I think. I hate imputing data. Does anyone impute data? It stinks. But sometimes it's necessary. And so MC often is used to sort of pull out imputation, although it's not all the time. There are other chained equation ways that don't necessarily use it. Number 2 is why I used it, lack of software capable of handling large size analyses. So for instance, if you have a zero inflated negative binomial outcome with 21 zero inflated negative binomial with 21 multivariate outcomes per 18 time points. Can you imagine that? What's a zero inflated negative binomial? Ugh. Anyway. Long story short is there's no way to handle that like in a longitudinal, like a multi-level model would be longitudinal. There's no way to actually do that well in a non-Bayesian way because oftentimes you'll put random effects in to describe each person's trend across time. And with a non-normal, or there's a very small set, non-normal can be tricked into it, set of outcomes, then you have to use what's something called marginal maximum likelihood, which means for every one of those random effects, you have to integrate over them in the likelihood function as you're doing the calculations. So it gets really, really hard. It takes a lot of dimensions to do. It's very difficult. So this is where I came into Bayes. The analogous part to this is, do you want to measure 10 traits with a single test? Have anyone tried to use M+ for a 10-dimensional MERT model? How about a 5-dimensional MERT model? It will tell you a warning, right? If you switch to categorical option and you tell it ML, it'll tell you a warning. It will say you have too many points, or too many integration points, right? Switch to Monte Carlo integration. It's bad, right? And then not only that, M+ is, I've found it to be numerically unstable, but that's me. I don't have a lot of data on that. I have circumstantial evidence that suggests why that could be. But I need the code, but that's it. What about this? This is my favorite. How many of you characterize yourself as a creative individual? Yeah, I do. I'm really creative. Like not with art and not with music. Like I dream up models. Like I express my creativity in crazy things that seem to work for for the scenario of the data that don't fit into some pre-wired package that I can use somewhere else. So the Bayesian software or Bayesian estimation allows you to do that, right? For instance, if you're doing, here's a simple case. It's not really creative, but it's how flexible it is. You learn analysis of variance. And you learn that homoscedasticity has to hold, right? What do you do if it doesn't hold? What do you learn about that? I'm just going to ask. I'm going to ask. We have a, what do you do?
What do I do?
Yeah.
I call you.
No, what I learned was you have to do some type of correction or transformation, something along those lines.
Oh, weighted least square.
Weighted least squares, which also is a pretty valid way. Why don't you allow different variances for different groups? Wouldn't that work? What's that?
You violate assumption.
What assumption? What if I assumed that each group had a different variance?
So now you have a different distribution.
I do, but we could do that. And that's the point. The part of it is, think of how statistics would have changed if we could have said, you know what, it's not likely that all my variances existed the same way. Okay, fine, I'll just allow every group to have its own variance. in least squares world, that is really difficult to do. You can't just go and tell your proc reg or proc GLM, I need a different variance. Maybe you can. Some of the software's gotten good. So, but back when it was created. Now, I don't know that that's better or worse. I don't have the background to be able to tell you that, but I do think of what you can do instead of saying what assumptions are. Well, you're making the assumptions. We sort of were taught, these are the assumptions. No. Those are the assumptions because we had to. What if you create your own assumptions? That's where I like to do this. That's where you can be creative, is what I'm trying to get to. Express your creativity. I know each of you have it in there. You're way more creative than I am, most likely. Finally, the last part. There are some people who are part of a cult. Maybe you are. That's okay. But do you know the people I'm talking about? I said this is my last time I was here. Like the people who are like, it's Bayes because Bayes solves everything. They're like anybody like chiropractors? Like the chiropractors of Bayes. Of like statistics. Sorry, I shouldn't say that. Let me remove that, strike that from the record. I have been to chiropractors before, so I can't, no authority says. But basically, there are people who believe Bayes does something mystical and magical with your data, and because of that, the results are purer and more, amazing, and that there's some key philosophical differences between the frequentists and the Bayesians and so forth. And that's cool. Maybe I don't fully understand. I haven't fully understood all of it. And yes, there are some really key differences. But the frequentist would always say, yeah, but we're the same when n gets large. And the Bayesian would say, no, not really, because it's still the philosophical differences. But the numbers are the same. But no, they're not really, so that's where the debate starts to be. But to me, I say that it's sort of jokingly. There's another cult I always joke about, which is the cult of Roche, like the Roche models. Right? Like if the Roche model doesn't fit the data are the problem, right? It's not that Bayes is not the level of cult as that. They're more like if Roche is like Dianetics, Bayes. I don't even know where I'm going with this. Scientology. No, that's Dianetics. Never mind. I don't know. Bayes is much more mild. They're much more mild. They allow people like me to exist. Although I may not. You may not find me next week. We'll see. I don't come back to class. He was murdered by a Bayesian. To say the least, the use of Bayesian statistics has been controversial. If you're around long enough and you visit places and you talk to the math or statistics departments where Bayesian kind of grew out of, they'll tell you about wars they had. I don't know if you've ever heard about it at Florida State. I went to a winter workshop at University of Florida once and heard about the wars that they would have at the stat department there. So it's been tough. The hard part is, prior distribution, the bottom line, to grossly oversimplify it, is the idea that prior distributions are subjective and science is supposed to be objective. And so how much influence does a prior have on the result, and how much does subjectivity bias the result? And that's sort of part of the argument, at least. So that's one of the problems. I'll just leave it there. I think in this day and age, you won't find a whole lot of controversy in Bayes, and I think the reason for that is Bayes is a real good means to an end. You see a lot of Bayesian in methods that work where frequentist ones or maximal likelihood-based ones won't, because of the way that computation works. All right, most of the methods that you find with MCMC, now remember, Bayes is not MCMC, right? It's not the 3-line equal is defined by, but most of what you see about Bayes is MCMC, this day and age. So MCMC methods are computationally intensive. Even with the most advanced, Stan is really quick for what it does. It still takes far longer for simple models than you would get with a ML-based software, right? If you put an ANOVA model in Stan, it'll go pretty quick, but it won't beat the seconds or the milliseconds it takes to get a result from a least square solution, right? So that's part of it. The other part that I found, this is an interesting statement because I put this in the text when I was working in a psych department in Nebraska, and I felt that a lot of people in the psych department were not as accepting of Bayes in 2012, but then in the years since then, it's certainly gotten much more accepting. And so this is sort of remembering what it was like to try to work with people, try to help them get their papers published in empirical psychology journals, and say, well, we don't accept Bayesian results. I don't think anyone says that anymore, which is great. It kind of shows you how much progress has been made for Bayesian as we go forward. So it's just really rapid in this scope of things. It's been 20 years in psychometrics where Bayes has been widespread. It's probably a little bit before. I mean, there were slightly, in the 90s, people were doing psychometrics and Bayes, but there's a great set of papers in the end of 1990s that were really good on that and really, really informative. And so it really changed the way we've done a lot of stuff research-wise. And here's an example. I just got this as I was making my slides. I don't know if I can. This is a European Journal of Statistical Modeling. These are the online first articles. Bayes, soccer. And I'll bet that one is Bayes as well too, right? So this is sort of the world I was like looking at this and making my slides, looking at my email, I'm like, this is really kind of a very, very small indicator. This is not the rest of the world, but it's pretty interesting how it works. So I think we're in line for a break. Thank you for correcting my math. Well, arithmetic's never been my strong side. What is chiropractic? Let's take a 10-minute break. Come back at 10:50, or if you have any questions or anything, you're welcome to come talk to me. So.